welcome to our series Larry Young, the Chief Product Officer at Phononic company. When you were in Stanford, do you thought about all of these innovations?
Started in high performance computing. We were connecting televisions to the internet, and that was when the consumer internet was dial-up. I do have 2 degrees, one in electrical engineering and the other in biological sciences. I was always trying to find that nexus between, well, what can we do in biology? What can we do in engineering? I had this crazy idea of harnessing your neural energy to power electronics.
One of the biggest products that you're leading, and as well you brought a lot of innovation, was FitBit.
I think first off was this trend of the quantified self. The very first FitBit had no UI. You just clipped it on. It was a simple band that you put on, and all those LEDs told you was your progress towards your goal. If your goal was 10,000 steps, then 1 LED would light up if you're 25% of the way there, 3 would light up if you're 75%. And that was it. No buttons to push. And then you go to your smartphone to get your data. This was a much better user interface surface for looking at your data, interacting with it.
What is Phononic? I would like to hear from you.
We understand the climate is changing, and anything we can do, especially with the demands of cooling ever increasing, we need alternatives. And it's not just better at eliminating those refrigerants. Hydrofluorocarbons are 2,000 times more harmful on the environment than CO2. Phononic builds solid-state cooling devices. This solid-state technology can replace the conventional form of refrigeration and cooling, which is using hydrofluorocarbon vapor compressors.
Hello and welcome to Dinis Guarda YouTube podcast show. Once again, powered by businessabc.net, citiesabc.com, and wisdomia.ai. We keep profiling the doers, the makers, and especially the people pushing the boundaries of technology. And in a world that has so much innovation, there's as well a lot of layers of understanding what is in front of the cameras, what is behind the cameras, and as well, especially when we deal with big AI tools or big technology tools or internet experiences. There's a huge amount of work behind the scenes that sometimes we forget. And that work is the data centers. It's all the things related, how we look at the different solutions that make our life easy. But at the same time, there's a lot of different things. So today I'm quite excited to touch a topic that is not so, I would say, mainstream, but is actually mainstream in terms of capital markets, because there's trillions of dollars being exchange in capital markets every day around these areas of data centers and solutions. And how you look at, first of all, put the amounts of giga or mega giga data systems that we deal and you create, all the data that you create every day, and the data centers that manage this. And especially right now, how we put this in terms of cutting edge AI data centers and the cooling requirements to keep this growing, and the electricity and all the needs. So I have a quite technical introduction. It's going to be a technical interview, and I'm very excited as well to bring personalities that can actually help us understand, and as well business that are quite solid that take this forward. So I welcome to our series Larry Young. Larry Young is a technology leader with an engineering background. He is the Chief Product Officer at Phononic company that offers solid-state cooling innovations, delivering high-performance, energy-efficient solutions for data centers, Opto, cold chain, e-grocery, pharma, and HVAC. We're going to explain all these terminologies. Phononic is a pioneering solid-state cooling and working with US hyperscalers to redefine thermal management. The company was recognized in the CNBC Disrupted 50 list of 2024. Larry held multiple top management positions at global corporations like Google, FitBit, Cisco, Microsoft, and Microsystems, WebTB Networks, to name a few. As the director of product management for FitBit in one of his previous roles at Google, Larry led Fitbit's core wearables portfolio, which generated over 1 billion in annual revenues with over 25 million active users. Prior to Fitbit, Larry spent 9 years at Google in senior product roles, leading connected TV platforms, gigabit speed internet and TV services, augmented reality, smartphones, and mobile app payments. And prior to Google, he built microprocessors, set-top devices, and game consoles, and video conferencing products at Microsoft and Cisco systems, respectively. So with a fantastic career that spans around 30 years of building products and platforms that connect people and businesses to groundbreaking new applications, service, and content, and working with the leading technology players in the planet. Larry was previously, as well, in his previous roles, vice chair of the organizing committee for the 2025 Odd Chip Symposium on high-performance chips. And from his education, he has in electrical engineering and biological science from Stanford University, and a master in electric engineering from Stanford University. And he has contributed to multiple publications, including System Design Methodology of Ultra Spark, and I'm not going to mention all, but just a floating point coprocessor for Spark systems. And Larry owns a patent for circuitry that detects the phase difference between the first base clock and the second derivative clock derived from the base clock. So, Larry, it's an honor to have you here, and I'm quite excited to go on the innuendos of a fantastic career, but as well all the level of expertise that you have.
Thank you, Dinis. Nice to meet you. Thanks so much for having me on your program here. I think my career arc really started in high performance computing. You mentioned Sun Microsystems. We're building high performance computers that were networked, which was pretty new at its time. I then went to a startup, Web TV Networks. We were connecting televisions to the internet, and that was when the consumer internet was dial-up. So it was very challenging connecting CRT powered televisions to dial-up, but again, working on integrating silicon and systems and software and connectivity. We then were acquired by Microsoft, so I went on to lead the Xbox console team, where we developed the first game console that had networking and connectivity built in. And so again, it was another opportunity to work on silicon and systems. I even led an internal custom silicon team. We were one of the 5 largest fabless semiconductor companies at the time, if you measure that in a number of wafer starts. So it's very new for Microsoft, but an important part of our strategy that I brought to that business. I then went on to join Cisco, working on high performance video conferencing for consumers. Again, a connected type product. And then went to Google, worked on connected televisions, led product for the gigabit speed internet project, worked on augmented reality smartphones, worked on mobile payments, and then went to Fitbit doing wearables and fitness and health data. And so the theme throughout my career has been integrating software and hardware and silicon and networks, and really working at the nexus of those technologies, working with engineers who are agile to really be intentional to make optimizations and trade-offs up and down that entire stack. Nothing happens by accident, so you can't just stumble into breaking down these silos. You have to be very intentional about that. And for me, it's also fun being able to work in such diverse, different technical stacks, and being able to learn and challenge myself across all of those.
And it's a fantastic career. Of course, you work with, well, the top 10 companies in the planet, let's put it that way, and as well in a massive amount of diversity of innovation and technology settings. So let's start with your career in Stanford, and or at least your studies and your base. So I think your career spans the beginning of the internet and all the expansion and explosion, and as well now you are as well in the cutting edge of AI. So give us a bit of that when you were in Stanford, do you thought about all of these innovations and all different things? A bit of your background from education and what brought you to become the product innovator that you are, and as well all this career amazing portfolio.
Yeah, I think when so my father was an engineer, and he would bring home interesting problems. He would tell me about, he was a mechanical engineer. He would tell me about automobile turbochargers, about, I don't know, the cockpit black box recorders, and share just some of the challenges that he had. I remember I remember when I was in elementary school, we had to draw a picture of our parents at work. And I had this like, I drew this picture of like big bookshelves and all that. And then I had a chance to go visit him at work, and it wasn't anything like that. He was sitting at a cubicle. There was a laboratory. There were whiteboards all over. It was just very amazing, that rich, interactive environment that he worked in. I even had the pleasure of doing a summer job at his company. It was at an aerospace company, Honeywell, um, and um, and got to work with programming a VAX 11780 computer. Was writing software for, I think, what turned out to be the F-35, but at the time it had some code name. I can't remember what it was. It was a long time ago. Um, and so, and even another summer job I had was at Xerox, and I got to play with the Xerox Alto, the predecessor to the Mac, and the mouse interface and the graphical user interface, and that was a lot of fun. So just getting exposed to technical problems, and then really shaping my education around that. So, as you mentioned, I do have 2 degrees, one in electrical engineering and the other in biological sciences. I actually started wanting to be a doctor, so I started taking all the biology classes, but then I stumbled into computers and just fell in love with that. But I was always, even then, trying to find that nexus between, well, what can we do in biology? What can we do in engineering? Um, I had this crazy idea of harnessing your neural energy to power electronics. And I think finally I'm starting to see some people do that. I was a little ahead of my time at the time. One of my favorite classes was learning um, how the brain communicates to your various sensory organs, specifically around vision, and all the pre-processing that actually goes on at the eye, at these nerve cells along the way to the optic nerve before it even hits the brain. So that was fascinating to learn about, and just bringing that engineer mentality. And I even use the term pre-processing. I don't think the biologists use that term there. So then, as I said, I fell in love with computers, and really, when I did my master's program there, started taking classes around computer architecture and learning about just how to optimize instruction sets. And that was in the time of the heyday of RISC computing, taking really simplifying the processor and putting more of the work on the software side. And by simplifying a processor, it can be a lot more flexible, run a lot faster, and let the software do all the customization. And so that delivered some good level of performance and lower costs on the processor, and sort of led to the rise of multi-core processors. And we can talk about all that later. But that type of work really fascinated me, and really decided to emphasize going into that. And then that's sort of what shaped my career afterwards.
It's very impressive, and we're talking about very, very cutting edge things mixed with a lot of products. And I think one of the things that is really astonishing in your career, that you're still quite young, is that you've been managing very advanced technical research and innovation. And like you just mentioned, a lot of different areas, some of them still shifting computer science, spatial computing, neural levels, and as well putting this into practicality of products and business. So how do you manage the balance between these things? And I think one thing that I think that's why Silicon Valley, where you are, is so successful, is that it managed to put very advanced research, but as well putting into products. Where, for instance, I'm in Europe, and I'm partly French Portuguese, or Portuguese with French, and being in the UK, I see that we in Europe we have so much research, but we are terrible putting it in practice. And I see, as a teacher, even in universities that I struggle sometimes even to put the students to understand that, okay, research is great, but you have to get it. So tell us about this balance between research innovation and put it in productivity of products and business.
Yeah, I found that to really find the right balance between innovation and practical products, you really need to understand first what is the problem you're trying to solve, what is the pressing need that a consumer or an enterprise customer, what are they trying to solve? And you really need to get in deep and in some cases embedded in really understanding that problem. When I was at Google, we did field research. I remember going on when I was on the mobile payments team, and we actually would go to field trips to Indonesia, and we would follow people around their day and looked at how they paid their gas bill or paid their electric bill or bought groceries and topped up their data plan, and just the way they did it was just very different than how we might do it. In Indonesia, just for example, is all about going to a convenience store. There's a convenience store on every block, and you go there, and there's a guy behind a counter or a gal behind a counter, and you paid your gas bill there. And you pay, you print out a little receipt. It's got a 10-digit code on it. You take that code back to your house, and at your gas meter, there's a little keypad, and you punch in the code, and then you're good for another whatever quantity of gas. Very different. And so you have to really get out of your bubble, understand what your customer is really trying to do, and then find the problems that are the most painful, because those are the problems where customers are willing to suffer or tolerate, maybe is a better word, any of the wrinkles or warts of an early innovative product. Um, I'm a big fan of Jeffrey Moore and the Crossing the Chasm work that he's done for decades now. And when you find that early adopter, you find the person or the team who just has the most painful problem. One of my favorite examples there was how Apple broke into the enterprise. Enterprise computing at the time was very tightly owned by the IT department. Every computer that gets deployed, the IT department has to configure it, and they'll tell you what kind to get and what software to load. And that was okay for like the finance people doing spreadsheets, but there was a department, the marketing creative department, that just could not use a PC. The software just wasn't good enough. And so Apple found a way to get their product in there. It was priced affordably, so the IT gatekeepers couldn't necessarily say no. And it was almost like a little guerrilla marketing thing where the creative team suddenly started using all their Macs, and they were like way more productive, and they were unshackled from the IT department. And this is the whole inspiration behind their 1984 the commercial, was just being unshackled from your IT department. Um, and there they just truly understood the problem, found the market segment that had a very painful problem, that they were willing to jump through hoops and smuggle computers into the office or whatever to solve their problem. So try to find those opportunities, and then start looking at your technology. What do you have? What's missing? Um, and then shape that. Don't be in an ivory tower and think you know whatever's right, and build something neat, and then go find a market for the thing you need, that neat thing you build. And then the last thing is just don't be afraid of iterating. So one of the cultural facets of Silicon Valley is not being afraid to fail. 9 out of 10 startups or something like that fail. And in some cases, entrepreneurs are rewarded for failing, because that proves they took a risk, and that they've learned something. And so don't be afraid to put a product out there, get that feedback, get the real feedback. What customers actually do is way more valuable than what they say they will do. So get the product into their hands, see how they use it, see if they don't use it, try to understand why, and then iterate that and improve on that. So really, it's just understand what the customer wants and tailor your innovation towards that, and don't be afraid to launch and iterate.
Wisdom and very important words. And I think, ironically, it's one of the things that I think only US and San Francisco have been leading on this. I think the rest of the world is completely obsessed about failure and testing and putting products. It's really it's a big challenge, and I think even with other things, and that brings me to my next question. But I want just to highlight, and I know that you are a mentor as well, and I think for people listening to us, and I have a lot of students and universities where I collaborate, even deans and vice chancellors. I think this kind of narrative is failing worldwide. It's
Mm.
not just Europe, it's worldwide. I think this is a big challenge for the world economy. And that's why the US, or especially Silicon Valley, created the players that play, because there's a huge sense of innovation, but as well test and fail and move forward. And I think that, for instance, in Europe, and I want to just share this, it's interesting to share with you, but
It's
I grew up in a both my part of the family that is Portuguese and part that is French, probably even worse, is being an entrepreneur is considered being a pariah. And even in the UK where I'm based, it's not so easy. So it's kind of the this kind of what is this man? And of course, he studied in Stanford, which was probably one of the most cutting edge universities, if not the most, at least in terms of percentage of innovation and as well products. But I just want to highlight this, and thank you so much for bringing this up, because it's one thing I think we should shout this to the world, especially for young people. And we have billions of young
absolutely.
people.
My wife is actually a college professor in her business school teaching entrepreneurship, and her entrepreneurship class is a requirement for all business students. And her mantra is, even if you go off and work for a big company, you're going to be expected to be entrepreneurial in thinking about, what does a customer need? What's a new product opportunity? How do you test and learn and all that? So that's in the water, in the air here.
Yeah, it's. I'm glad that this is. I think I wish we had this more in Europe. So next question is: so one of the biggest products that you're leading, and as well, you brought a lot of innovation, was Fitbit. So for people listening to us, Fitbit is a brand of wearable fitness trackers and smartwatches that focus on helping users monitor their health and activity levels. And these devices track various metrics like steps, distance, calories burned, sleep patterns, and so forth. And some models offer smart features, and you touch some of these things that can be used. And as well, I think it was probably the biggest smart wearable that became mainstream in a big scale, millions of people, like I mentioned before. So, from your work on Fitbit, and Fitbit was something really massive, cutting edge that became adopted by I think 23 million people or plus. So, tell us about the key factors that help Fitbit achieve such significant success, and as well your working experience on this product. Of course, the product you left, but you were actually one of the people that were one of the architects.
Yeah, I think there were a couple of things that really came together that led to Fitbit's success. I think first off was this trend of what we called at the time the quantified self. I think there was already a trend towards appreciating data, collecting data, measuring what you do. And so there was a curiosity about, well, how many steps am I taking? And what is the right number? What is my heart rate? What is the right range of my heart rate? So that was already a consumer trend. And then I think the genius that the founders of Fitbit, James Park and Eric Friedman, had was simplicity. The very first Fitbit had no UI. There might have been an LED that told you if the battery was dying or not, but that was about it. Everything was on the smartphone, right? And so by having that simple UI, there are no buttons to push. You just clipped it on. Their next one was one that did have, I think it's four LEDs on it, but that was it. And it was a simple band that you put on, and all those LEDs told you was your progress towards your goal. If your goal was 10,000 steps, then one LED would light up if you're 25% of the way there, three would light up if you're 75%. And that was it. No buttons to push, no. And then you go to your smartphone to get your data. And I think the simplicity is what really led the product to succeed. One of my product design mantras is the best UI is no UI. If there's no buttons to push, then the consumer doesn't worry about whether or not to push the button. Um, and the smartphone, was also, I guess, the other trend taking off. And so this was a much better user interface surface for looking at your data, interacting with it, et cetera. You also didn't want people to necessarily fret about their steps all the time, looking, 5 more steps, 6 more steps, right? So you really wanted to just be kind of a little bit in the background. It was doing its job. And so that simplicity kept us going for a very long time. Eventually, there were some information you wanted to see. You wanted to know your particular heart rate at the time. Became inconvenient to fumble for your cell phone, for your mobile phone. So okay, let's display that. But we always took that minimalist UI approach, and I think that was pretty key to the success of the product.
I love what actually this become a master class. So Larry, fantastic. I interview for other people, and you've been pushing a lot of fantastic pearls of wisdom. I'm very excited at a lot of the things you said, and this probably is another area that I'm completely obsessed about product, and to be honest, I think you synthesize more than I probably learned in a couple of years
Thank
in
you
this
so much.
part. So fantastic, and I'm being very honest about that. Probably very emotional on that because it's really an area that I think with all the people I've been working is, and I work in banking, investment, and products that cost millions of dollars, and sometimes it's the overcomplication that is kills products. And I think FitBit is an example of fantastic engineering and minimal and as well a product that is super cutting edge because in the end of the day you're dealing with your health, with data and everything else in one place. So continue on this, and there's a lot of questions here that I have. So you are right now, and of course your career spans so much fantastic products because you work with really amazing things from Xbox, a lot of different things. Let's go to your present role in Phononic. So first of all, what is Phononic? I mentioned a bit in the beginning, but I would like to hear from you, and you are actually very good explaining. So I'll pass the word, and this is a fantastic company. We'll put all the links, but coming from you.
Yeah, so Phononic builds solid state cooling devices. We use a material called a thermoelectric material. That's a material that has a property where if you apply an electric current, one side gets hot and the other side gets cold. And if you reverse that current, the other side gets hot and the other side gets cold. Think of it as like a miniature heat pump with no moving parts. So we build these chips. We also build the subsystems that go around it. We also have software control. We have an IoT cloud that we can send data to, that we can analyze energy efficiency, utilization, error states, and all of that. So I have some examples here. I'm going to see if I can get it to work here on my virtual background here. So up here is an example of some of the components. You can see they're very small. It's about the size of a grain of rice. So we can make very small ones. These we would put on top of lasers at the ends of fiber optic cables that keep the lasers cool. I could talk more about all of that a little bit later. We also make larger ones. This one can go into a refrigerator. These are actually double stacked ones we can make freezers out of. And then we'll actually build modules of them, and in some cases encapsulate them, so it's easy to assemble and test. What brought me to Phononic actually was the fact that this solid state technology can replace the conventional form of refrigeration and cooling, which is using hydrofluorocarbon vapor compressors. Hydrofluorocarbons are 2,000 times more harmful on the environment than CO2. And as we understand, the climate is changing, and anything we can do, especially with the demands of cooling ever increasing for all of the demands and use cases that we've been talking about, now more than ever, we need alternatives. And it's not just better at eliminating those refrigerants. As you can see from what I just showed you, the form factor is extremely small. And so we can use it in places that you can't fit a vapor compressor in. It's solid state, so it's much more responsive. So we can bring cooling on demand when you need it. where you need it. And so that results in an energy savings as well. And we can talk a little bit about that in some of the applications. And it results in space savings. In some of the grocery stores, for example, space is at a premium. So we've delivered solutions that take up half the space that a conventional approach would take. And it frees up that space to do many other things for that store. So solid state is no moving parts, safe space, on-demand cooling to deliver energy efficiency.
Well, that's first of all, is a super cutting edge. So let's go from the theory to the practice. So some of the things that you're touching, and I want to go here. So you have this material you mentioned can be used for a lot of different areas. So from data centers to opto electronics, cold chain, which you touch partly, and HVAC. So a bit, if you can bring a bit of I think for people, because of course, if you are working in any computer, if you're using ChatGPT or if you're using anything or a wearable, like we mentioned before, you need this kind of cooling systems. And of course, if you're using a refrigerator or things like that. So tell us a bit about from these four angles that you guys have mentioned, a bit of a case study, probably in a short way, for data centers, optoelectronics, and cold chain in particular.
Okay, let me start with the cold chain one, and then we can move to the data center one, because I think the data center one is a much longer and deeper topic.
Yeah.
For cold chain, we built the world's first solid state powered grocery freezer, and it's a tote size form factor. It's about yay big, foot and a half by 2.5 feet. And when you place, if you think about what happens when you place an online grocery order, you place your order, and then there's some operator at a grocery store who's running around the store doing the shopping for you. They go to the refrigerator section and grab your milk. They go to the freezer section to grab your ice cream. And then they take it to a back room. They call it a staging area. And in that staging area is a completely duplicate set of reach-in refrigerators and freezers. He'll put your milk back into another refrigerator. He'll put your ice cream back into another freezer. All of those freezers and refrigerators are running 24/7. And then when you pull up to pick up, or when your gig worker comes up to pick up your order, that operator has to then open up that duplicate set of freezers and refrigerators, pull out your milk, pull out your ice cream, and bring it out to you. And so when you look at that whole workflow, there's two major inefficiencies. One of them is in the industrial engineering time and motion optimization world, they call it touches. Every time an operator touches something, like opens a lid, pushes a button, whatever, that is inefficient from a labor productivity standpoint. And so they are touching your product multiple times before you finally get it. So that's one problem, is labor efficiency. The other is the energy efficiency. That store may only have one pint of ice cream being ordered, but they have that room full of refrigerators and freezers still running 24/7. Huge waste of energy and huge waste of space. So what we've done is we've developed this tote, as I mentioned. It's a fairly desktop size type of a tote, and the operator can now bring that tote out to the store floor. Put your milk in a refrigerator tote, put your ice cream in a freezer tote, bring it back to the staging room, and just leave it there. And then when you pull up, they then wheel the tote out, and then they pop your milk and your ice cream into the trunk of your car. Way fewer touches, much less space, and much less energy being used. And so we've deployed this product at Sam's Club. A couple of Sam's Clubs are now using it in the US. There's a grocery store chain called ShopRite that's in the Northeast of the United States. They've adopted this in a number of their stores. They're seeing the space savings, the labor savings, and the energy savings. And all of this is made possible because of the solid state technology. We can turn it on and off quickly. We can maintain a tight temperature control. It's IoT connected, so we operate an IoT cloud, send all the data there. We can send them alerts if there's a temperature excursion. We can help them manage their energy. and there's no moving parts, so definitely maintenance savings there as well. There's another aspect of cold chain which we should touch on, which is pharma. Retail pharmaceutical drugstores in the U.S. have have a bit of a crisis in that the demand for drug pickup is outstripping the number of pharmacists that are available to work at these drugstores. And so there's an emerging model amongst the pharmacy chains and operations to do what they call central fill. Fill a customer's order at a central sort of hub facility. So you have fewer pharmacists who can really focus on filling prescriptions. Another problem with pharmacists in the retail location is they get distracted with customers who are like, I can't find the potato chips, and that type of thing. So at a central fill facility, these highly trained and well-educated pharmacists can focus on doing pharmacy by ensuring that there are no mistakes, that prescriptions are filled correctly. And then when the excuse me, when the prescriptions are packaged for a particular customer, those prescriptions are then delivered to the spoke store so that the retail pharmacists can double check the customer's identification, and then give them their drug. Many drugs require temperature control, and so we've delivered our tote solution to a grocery store in the Midwest of the United States called Meijer. They are running this type of central fill pharmacy operation, and they can use our totes to keep prescriptions at temperature control, so that while they're processing all of these different orders, and then they can bring and then when the order is ready to then get shipped to the hub store, they've been maintained temperature the entire time. So similar cold chain. It is a cold chain fulfillment application, but not just groceries, but also for pharmaceuticals. And then there's another aspect of cold chain called last mile. I sort of mentioned in the e-commerce grocery situation that a gig worker might be picking up your order. Well, in some cases, the store themselves also have a delivery service. So they have their own vans, and they have a challenge with maintaining temperature. They don't have good options. One might be to run the whole van at temperature control. Wastes a lot of energy doing that. The other option is use dry ice packs. Dry ice is terrible on the environment. The energy required to make the dry ice for one order is like running a hair dryer for like 2 hours, right? Just to make the ice for one order. That amount of energy is being wasted. And then of course it's a hazardous material, so it requires gloves and then of course it's CO2. You're literally evaporating CO2 into the environment. So our solution is being deployed in last mile delivery vehicles as well. So you can keep your ice cream frozen in just where you need it, and your milk chilled just where you need it. And you can turn off once you've made the delivery, you can turn off the power to our tote, so it saves energy. So these are just some of the examples around cold chain fulfillment that we've been deploying in.
That's a very impressive and a lot of work there. So I want to come back to the data centers, which for me it's particularly important because of course I discuss a lot of AI in this program, and as well I'm very involved in AI myself. So there's a lot of myths around AI and data centers. There was actually, I think, former CEO of Google that mentioned that the AI data centers will take a huge chunk of all the energy of the United States. And there's a lot of, I think, some absurd topics and others less. And there's a lot of confusion. But well, before we go there, you guys launched a fantastic paper. I've been reading about it. That is, the name of the paper is Meeting the Unmitigated Data Demands of AI, Design Capabilities that Meet the Cooling Requirements of Cutting-Edge AI Transceivers. So could you highlight about this? And I think this is a topic for everyone listening that I would say that 99% of people have no clue. And of course, what you get in the mainstream media normally just creates more paradox because there's so much contradiction. Some people say one extreme, but I know that there's a lot of research. There's a lot of course, optimization. But tell us first about the paper. I think it's interesting and the work that Phononic is doing on that. And second, a bit if you can bring a bit broader your views about AI data centers, a bit of reasonable scientific approach how we can tackle and what's the situation on that from a more mainstream perspective and the effects in society and electricity consumption and as well all the areas that you guys are optimizing.
Yeah, absolutely. I think at the heart of AI or cloud computing or even blockchain mining is a computer. And there's two aspects to the computer that are important for delivering its performance. One is, of course, the processor itself, but that alone is not enough. You also have to connect many processors together. And so the network is also very important to bring together. So I'll touch on the network piece first, because that's where Phononic sort of got its start. Um, um, Most of the data that's being sent around the world and even between or inside data centers are sent on fiber optic cables. Fiber optic cables are strands of glass with lasers that sit on the ends. The lasers are sending the data. You know how data digital computer data is digital data. When you come down to it, it's a series of ones and zeros. And so you can imagine when a laser is sending the ones and zeros, it's using one frequency for the one, another frequency for a zero. So imagine a violin, and one note is a one, another note is a zero. And when it plays the one note, it's sending a one, and it plays a zero note, it's playing a zero. Now imagine Itzhak Perlman is playing this violin, and he's changing the notes at a trillion note changes per second. So it's a very quick transition. But another thing happens is if this violin is really playing that quickly, it's going to probably get very warm, just from all the friction and the motion and violin strings are made out of metal. As it gets warm, it's probably going to deform and it's going to get out of tune. That's what is going on when a laser starts sending data faster and faster and faster. It gets hot, it gets out of spec, and it gets literally out of tune because it's no longer sending at the right frequency. And so that's where we come in. These little chips I was showing you earlier, they sit on the ends of sit on top of the lasers that are inside these optical transceivers. Transceiver means a transmitter and receiver. It's a single module about the size of your index finger. And it sits on the end of the fiber optic cable. And our chip keeps the laser cool, keeps the laser playing in tune. And we've been doing this for about 8 years now. We've shipped over 30 million devices that cool these lasers, and that number is growing because as data rates get higher and higher, the demand for lasers to go faster and faster is ever increasing. Our our solution is in all the major hyperscalers. We're in Google, Amazon, Microsoft, Meta, etc. We're at the ends of fiber optic cables that go all the way to your central office, and they to your telco central office, your ISP server office. We're at the ends of cables that go to your home or your office. We're at the ends of cables that go to cellular towers as well. So everywhere there are high frequency, high bit rate fiber optics, we are there cooling that. So that's the networking piece. I can go into the processor piece. I don't know if you had a follow-up question on networking.
No, I think on this is great. So just for people listening to us, because I think, of course, you are on the part of cooling the computers and all the processes within the data centers. I want to just probably to explain for someone that is not so technical, if you could just bring from the work you're doing, because for instance, your work can be applied to a lot of different industries, and you mentioned a couple of them, but keeping on the narrative around the AI data centers, how we work. For instance, let's say we have the NVIDIA, and actually I brought a couple of directors of NVIDIA to this podcast, but of course we spoke bigger topics. But I want to go this because I think one of the problems with the I think knowledge, and of course especially nowadays, is that we can put everything in the same box and no one knows what is working behind these things. So
Right.
let's look, for instance, on the case of an AI data center, and we come back to some other things of phononics. But in the case of an AI data center, let's say we're using NVIDIA chips in a big scale, or I don't know, one of these, any AI tool without mentioning too much brands. And where do you come and how this works together? I would like to, a bit like an orchestra, if you could put the architecture, how this works for a bigger audience that I have.
Yeah, absolutely. So I talked about the networking piece, and now let me talk about the processor piece. Which is
Yeah.
where I think you wanna focus on. One of the things that sets an AI processor apart from a general purpose processor is the fact that it's using a GPU, a graphics processor unit. Now, graphics processor units were traditionally used in gaming applications, but what's unique about its architecture is it is massively parallel. If you can take a task and break that down into different chunks that can then be operated on in parallel, you get massive acceleration. And the way AI algorithms work today, they're very well custom, very well formed for that type of application, for that type of a compute architecture. And so that's why you see NVIDIA, they've been the leader in graphics processors for decades now. They're very well positioned to continue that computing paradigm and really support the AI processor. What that means from a power standpoint is that now a lot of the chip is operating at the same time with a general purpose CPU. Because everything is serially working, you'll have one part of it working, of the chip working, while the rest of the chip is waiting. And the circuits that are waiting don't use as much electricity. Well, in a GPU, think of it as like thousands of processors now, all busy, all at the same time. The power demands and then the thermal demands just really skyrocket. Today's AI processor chip module uses about 1,000 watts of electricity, which means there's 1,000 watts of heat coming out. Every watt of electricity that goes into a data center results in a watt of heat that has to get out. So 1,000 watts is like a clothes iron is about 1,000 watts, but the AI processor itself is the size of half a credit card, which is the tenth the area of a clothes iron. So that's got 10 times the heat density of a clothes iron. You will burn your fingers if you touch it. In fact, earlier in my career, I was curious about if a chip was actually powered on, and I actually, oh, it should feel warm if I touched it, and I burned my finger. So don't do that. It is, you will burn your fingers. Um, in a typical AI data center rack, you'll have like 100 of these processors. And so now you're talking about 100 kilowatts of electricity going in and 100 kilowatts of heat getting out. That amount of heat is like 16 double burner Weber barbecue grills all packed inside the space of a phone booth. So it's a ton of heat, 16 grills worth of heat packed in a very small space that has to get out. And when you just keep going, when OpenAI talks about their 5 gigawatt Stargate data center, 5 gigawatts is enough heat to keep a city twice the size of Detroit, although keep a city twice the size of Detroit warm throughout an entire Michigan winter. So this is phenomenal amounts of heat, not just in density itself, but also the total amount of heat being created.
Well, that's and I think this is the part that I wanted always to highlight is the complexity and the power of the things that we're talking here. So one of the keeping in what you have, and I think I'm particularly interested because you just mentioned, of course, now we went to the data centers and the impact of the data centers. So what you guys launch a paper and a book about cooling innovation for warming planets. I know that this is an area that you guys over there in the US have a lot of contradictions, especially from a government and non-government, but it's a key element for everything, especially in the industry. And the book is a very interesting area. So cooling innovation for a warming planet is a fantastic, and you guys are very generous to offer to anyone to read it. So one of the things is that you touch is the firestorm over cooling, meeting the climate moment with solid state technology and solid state innovation. So can you highlight, because you mentioned how he I think we have a paradox from a communication is that in one end we have all this innovation and then you cannot fix a lot of problems. And I always try to see micro and macro. So from this research that you guys publish, and of course this touch about ESG, environment, sustainability, and governance, that is part of the research that you do. But from the perspective of Phononic and the research that you did with, which is very important to demystify a lot of things, and how can we manage this in a kind of a wise way, these topics, I mean.
Yeah, I think there's two aspects to it that I consider. One of them is, I'll call it the inevitability of needing to solve this problem. Say whatever you want. The economics and the physics are right staring in front of us. And then the other is, this is where innovation shines. I mean, I talked about earlier, when there's a big painful problem, that's when innovation has the best opportunity to take root. Um, if you look at just the data center stuff we're talking about, and when we wrote that ebook, data centers we knew were big, but the AI boom hadn't really taken foothold yet. Um, there is a warming trend in the world. We are generating more heat, period. That's just a fact. AI just adds on top of that. And so there needs to be solutions to this. Even in the AI world, for example, or in the data center world, 40% of all the electricity that goes into a data center is spent on cooling. That has to get better if the data centers are ever going to get more efficient. And so we actually have products that make computing more efficient, because we can deliver cooling on demand. We don't need to be overcooling things. Today's data centers, they are running their liquid cooling system 24/7, just like those reach-in refrigerators and freezers in the grocery store. They're running 24/7. It's very slow and unresponsive. And so they find the component that has the most demanding cooling need. They set it to meet that component's need, and then they leave it alone. And so most of the time, they're overcooling the rest of the system. And even the workloads across the day vary dramatically, yet they're still overcooling even during the low times. Our solution is small, so it can bring point cooling to just where it's needed. It's fast responsive, so you can turn it on just when you need it. We built a product that fits in a desktop PC. This is about 7 years ago. It's a product called Hex. I actually have one here, and it is an on-demand cooling solution. And we benchmarked this against a traditional liquid cooling, and we found that it delivers 40% higher compute performance per joule of energy that is spent. And so I think these require a solution to it. AI is just one of them.
Fantastic, and very straightforward on this area. So continuing, so and now shifting a bit from the cooling to innovation and the impact you had in terms of consumer electronics. You've been involved in creating some of the most impactful technology in consumer electronics. We mentioned about FitBit, but you have been as well involved in augmented reality smartphones and connected TV platforms that you mentioned before. So how do you see this evolution of all these technologies that all use these chips and all this energy and all these different parts, and the work that you're doing right now converging in Phononic to drive even further innovation? But how you see this going? Because of course you mentioned the even the paper that you just highlighted was still in the beginning. Now with AI, this is multiplying by thousands and billions, but and there's an exponential growth. So I want to see from how you see this exponential growth from a perspective of technology, energy, and innovation, and how you can put all of this in a balance.
Yeah, I think what's amazing about consumer products is the the drive for varying form factors, and how innovation has met the need for different form factors. So over 100 years ago, So Sears Roebuck and Company, now a defunct company, had a mail order catalog. They're probably the first e-commerce company over 100 years ago. In their catalog, they sold a motor, and the motor had different attachments. It had a mixer attachment, it had a blender attachment, it had a juicer attachment. Um, and that's because motors were expensive and they were hard to make. Um, and today you can't imagine. Now we have our an immersion blender, a regular blender, our own mixer, hand mixer, juicer. We'll have five of these appliances now for probably less than the inflation adjustment price of that original multi-attachment motor. And that's because motor technology, has evolved incredibly over 100 years and has met the demands for consumers. Um, Another great example is the mobile phone, right? So computers used to fill a room. And now you have multiple computers all around you. We're probably talking on one, but then we have one of these in our pocket and we're wearing one of these on our wrist. And, if you just go around the house, you probably didn't realize it, but there are all these invisible computers all around you. And that form factor demand has driven a lot of what is going on here in computing innovation. And I think refrigeration is now at that moment. Right now, the old, I don't know how many year old vapor compressor is at a crossroads. I think there's two problems. One is the hydrofluorocarbon refrigerant problem. It is now recognized to be a toxic material that has to be eliminated from our use, just like we eliminated fluorocarbons to save the ozone. We will eliminate hydrofluorocarbons to save the planet, and that's happening, and that's not going to be reversed. But I think the other challenge, sustainability is not enough. You also have to solve an actual consumer problem, and I think the actual consumer problem is if you think about all the things in your house that need cooling, your makeup, your breast milk, your Ozempic. Um, these are all things that need refrigeration. And right now, there's only one place you can keep it, and that's in your kitchen refrigerator. Some of those things are rather personal, and the kitchen refrigerator is a somewhat public place. If you have guests over for a poker night or for your book club and they want to grab a drink, they're going to go into your refrigerator and they're going to see, oh, what do you have? What's this? Um, and so, wouldn't it be great if you could modularize refrigeration and just push it out into all the different corners of the house that you need to? My niece actually already has this. She uses makeup that requires temperature control. There are these little makeup, thermoelectric powered makeup refrigerators that you put on your bathroom counter that you keep your makeup in. And so we're starting to see that trend of refrigeration form factors evolving because of consumer demand. And the good old 100-year-old vapor compressor is just not equipped to meet that need.
Yeah, and we're just in the beginning. There's a lot of work that is coming out of there. So, you are a leader in high performance technologies, and you touched a bit now about the innovation that is necessary to keep this path and velocity. Uh, what do you believe is the next big breakthrough that we'll see in the fields of this area, especially in sustainable energy and technology, or cooling and the sustainable parts, but as well on putting together this orchestra? Because I think the biggest challenge, and probably the companies like yours, is the capacity to find the balance. Because as we get more consumption, AI, if the data center, cloud computing data centers would consume a lot of energy, now we're talking big levels. And it's not just that, because even right now, like you mentioned, a refrigerator, a thermal system, a lot of the things you guys are managing, all of this consumes, and there's integrated data. So, and as well, there's a concept, of course, of digital twins that are integrated. You can actually have a digital twin for this. And I know that from what I've been studying, I think the digital twin can be used with AI LLMs to understand and measure all these cooling systems and integrate it. So I would like to see, especially, see these levels of innovation, and what are you doing on these directions?
Yeah, I think Yeah, the demands on cooling and energy are real. You talked about digital twins. There's a gentleman at NVIDIA who you've probably met, Ali Haidari. He leads their thermal work, and NVIDIA has done this amazing job of a digital twin of a data center that includes, not just the physical model and the electrical model, but the thermal model of it as well. So you can actually plan out your entire data center build before you actually build it, do all your thermal modeling and your simulation. And then while the data center is operating, you can be monitoring it via the digital twin and do experiments to see how you might be able to improve the efficiency. Um, and that's an amazing, it's a huge problem, the thermal management of a data center, and what NVIDIA is bringing to bear to solve that problem is truly amazing. Um, I think just in general, with the problem comes innovation. Even in these mobile phones, there are thermal challenges, and you've probably experienced your phone warming up in your pocket because of some thermal runaway situation. When you take this phone apart, you will see there are heat sinks and fins. There's another company um, that is building a MEMS-based microfan that actually can blow air, very small amounts of air, but small amounts of air in a very, very small form factor that can really move the air in the very small form factor. So that's another innovation that's going on. And then of course there's us. I think because we can move quick, we can respond quickly, we can deliver responsive cooling in very unique spaces, and we can turn it on and off to cool different components within the data center. I think there's another area which is a longer conversation, but there are the different liquid loops within a data center, and those liquid loops need to operate at a particular temperature, and eventually that loop has to exchange its heat out with the open air. And so when you look at a picture of a data center from the outside, you see these giant cooling towers. Um, these towers have two challenges today. The worst ones are the ones that use hydrofluorocarbon vapor compressors, and those use an incredible amount of hydrofluorocarbons, refrigerants that leak and need recharging and all those other awful things. So that's generally regarded as awful, and they're starting to phase those out. But the next thing you'll see is that sometimes you'll see these cooling towers emitting steam. Um, and that's because these are evaporative coolers. They're actually spraying water on these hot elements, and then the water vapor then evaporates. That uses an incredible amount of water. We talked a lot about electricity usage, but the water consumption of a data center is another huge challenge. And so if we can increase the temperature for every 1 degree increase of that liquid temperature, of the temperature of the liquid loop, there's a 2 to 3% decrease in the overall energy and a reduction in the overall water consumption as well. And so by using our technology, all liquid loop can operate at a warmer temperature, and then save energy when you're venting the heat out of the data center. So that's another area. It could be its own long conversation about how we're working with a number of the data center facility cooling people to bring our technology to help solve that problem.
And that's a big business that I think is going to be increasing. And I think, like you mentioned, there's electricity, the water, and we need innovation from the cooling systems, but as well from the architecture that we have behind it. So my last two questions, I know that it's been a kind of marathon and it's quite technical, but it's amazing knowledge that is here. So you're the vice chair of the Odd Chip Symposium on High Performance Chips. So you, in this role, of course, you have a lot of innovation, especially in the semiconductor industry. And the other day, it powers everything. And we mentioned NVIDIA, but there's from Cisco, from all the different tech, I would say all the tech that we use anywhere in the world. So tell us a bit about the symposium high performance chips and some of the innovation that you're seeing coming out of this and what you want to share here with our audience, some highlights that you might want to share.
Yeah, I've been involved with the Hot Chip Symposium now for several years. The conference itself is over 35 years old. I attended the first couple of them, and then been involved off and on. And we like to pride ourselves on being a conference for engineers put on by engineers. So it's 100% volunteer um, team that puts the not only puts the program together, but we also run the production, we run the catering, we bring the ice cream, we deal with parking. So it's very volunteers. But it's made up of these very successful computer architects that have worked at Intel, AMD, IBM, Meta, Google, all the big players. These are engineers who really believe in their work, but more importantly, believe in the importance of sharing the work between our communities so that we can build on all of our ideas and continue to innovate. That's another culture at Silicon Valley is we like to share our ideas. We like to meet and build on each other's ideas because that's the only way to really drive innovation and learn from each other's mistakes so that we can continue to grow. Um, the trend I've seen over this conference has been incredible. At the beginning, it was all about um, processors for personal computers. That was kind of the thing at the time, and then computer workstations, um, single chip processors that morphed into multi-core processors as Moore's law moved on. We can pack more actual processor cores onto a piece of silicon. We start bringing other parts of the system onto the silicon. And then I remember a talk from NVIDIA, it was probably Jensen, who gave this talk maybe 15 years ago about how the GPU was a game changer as a general purpose computer because so many of these workloads could be parallelized, like I mentioned earlier, and the GPU is perfect for that. And those were early days of massive parallel processing, and it was a pretty bold flag that they planted at the time. But now, they were completely right. The AI workload being massively parallel, and the GPU perfectly suited for that. So that trend was, I'll say, predicted at the Hot Chips conference several years ago. And last year's program was primarily an AI theme. I expect this year's program will be as well. We are driven by the submissions. We invite authors to submit papers of work that they're interested in or they think our audience will be interested in. So it's a mix of company papers as well as academic papers. It's from the US. We've had presenters from China. We've had presenters from Europe. There is innovation there, so they will submit and they'll come and present their work. Um, and like I said, it's probably going to be mostly AI, probably three-quarters AI. We like to carve out we like to hold a quota for non-AI, otherwise it would just become an AI show. And so we'll have embedded processors or network processors. And sometimes we have interesting topics on programmable processors or some software paper or even a thermal management paper. So it's going to be another great conference. We had a record attendance last year. We expect to continue that and break that record again this year. It's in late August. It's held live in person at Stanford and Stanford University in California, and is also available streaming online.
Congratulations. It's a fantastic and great research and coming and a lot of solutions. And I love the fact that it's an industry based by the community, which is, I think, key thing for everything we're doing. So, and a bit to wrap up, although I have still a lot of questions here, I think we might do a take two more technical.
I love that.
So,
Yeah.
so now there's a lot of learning. I'm learning a lot, and I will be preparing some other things. But so you are in the intersection of engineering and product developing, and that's amazing. Your profile and as well your deep levels of knowledge. So we discussed the challenge in terms of cooling and what you guys are doing in Phononics. And as well, a lot of the work is putting together this behind the scenes solutions that make our lives easier, our performance of our companies, our data centers, but as well, like you mentioned, I think for us, one of the things you guys do is as well you have a lot of solutions that touch almost anything from retail to different parts of what you do. So from this innovation, and I think probably two-tier part of the question. So from Phononic, you guys are touching e-grocery, last mile, and then you have automation and robotics and pharmaceutical. So you have, of course, there's all the part of all these cooling systems behind the data centers, behind the systems and the materials and the engineering products. But there's as well innovation that you see going forward. For someone that worked with Microsoft, Google, and in this case, and Cisco, and even Microsystems, and now with this company that is, of course, quite young still, how they see the future for the company and as well in the industry in general on these areas and other areas that you are passionate personally?
Yeah, I think there's two parts to that question. I think one is how how do we scale, and then the other is like what might be the problems to solve in the future. I think the scaling one is a lesson I really learned across all of these companies that I had the privilege to work with. It's not enough just to have the one good idea and then solve that one problem. If you really want to make an impact, you have to figure out how to scale that solution. And there are a number of different ways you do that. You know, building a software platform or app ecosystem would be a way to do it for if you're building a software product. I think when you're building a hardware product, our lesson that we learned early in the early goings, we cannot build every single product that can use our technology. We actually tried to do that. We have our little facility in Durham, North Carolina, and we just can't do that. There are other companies who are just much better at understanding their customers, at defining products for those customers, distributing into those and selling to their customers. We can't be all of those things. And so we've adopted a licensing model now where we will build the thermoelectric chips, not just the chips, but the whole subsystem around it, the heat exchangers, the control software, the cloud software, and we will license that to different companies. So let me talk about the tote example, for example, for cold chain fulfillment. There are customers who want a different tote. They want one that's a little taller. We have one customer who has robots that do automated warehouses. It needs different grips and different interfaces for their robot. Well, we're not going to go build a tote just for them and build another tote just for another automation company and build another tote for another, right? So we'll license them the design. Here are your rights to design. You can modify it however you want. And so we're taking that licensing model everywhere across our business, even across the AI data center area as well. So I think that's one. Scaling is very important, especially for a startup, and that licensing model is critical to that. And then I think where this is all going, when I was at Google, we had an expression, never bet against bandwidth. We knew that if you sped up a search result, billions of revenue go up, right? There's a very clear correlation between speed and revenue. And even Jensen Huang at his GTC keynote, he literally said, your revenues will be limited by power, by your electricity and your cooling capabilities. And so don't bet against the demands, the economic demand that is driving increasing network, increasing performance. That drive will always be there, and thus the challenge for thermal management will just continue to increase. And with that challenge and those problems come opportunities for innovation and building amazing new technologies and products and helping those customers.
Fantastic way to go, and I think very inspiring. I know as well that you are a mentor and you do a lot of work in terms of putting together. You mentioned the conference. So just one final word for our audience and for young people listening to us. And I think in the beginning you mentioned the importance of entrepreneurship, not being afraid of failure. And you just finished right now as well, touching the importance of not underestimating this. And I know that, of course, you guys are in Silicon Valley. You are a bit, I would say, not a bit. You are far ahead. And of course, my channel portrays this far ahead. and my audience is as well. But I feel special the geopolitics and as well the difference in terms of culture is a key element as well to look at this. So last one is a bit inspiring for young people listening to us, and you're quite a mentor yourself. What is the advice you give them and the opportunities you see? Because of course, at the moment when you think about AI, there's a lot of disruption, there's a lot of things, but there's a lot of opportunities like your company is showing. So I would like to push all is the more awful opportunities that are here and how people can leverage that.
Yeah, I think so. I actually just wrapped up with a mentor group a couple of weeks ago, and my sort of parting thoughts to them were twofold. One is always work on the most important problems. Work, and sometimes those are also the hardest problems. Um, if you're at a company, especially a big company, um, challenge yourself, try to get involved in understand the company strategy first. um, don't just let it be told to you. Be inquisitive and curious and really seek to deeply understand the company strategy, and from there you will then understand what are the priorities and the most important problems and work on those. Even volunteer your time if it comes down to it, because those are the problems that will get the most resources, the most attention, and drive your career growth. So I think that's one. And the other is work on things that you're curious about. In some cases, work on the problems that are fun to solve. If you really understand what motivates you to get up in the morning, what types of problems you like solving, um, and then try to prioritize along those lines as well. So really, to sum it up, it's work on the most important problems and have fun while you're doing it.
Fantastic inspiration. Larry, it's been a truly honor and I learned a lot and a lot of things made me think and potential. I'll come back to you with a couple of other things, but congratulations to your work and to your achievements in terms of your career, as well your dedication and hard work. And as well for people listening to us, please learn, engage with Phononic and as well with Larry Young. Thank you so much for being here.
Thank you so much. This was a lot of fun.